Assalamualaikum and greetings to our lecturers and my fellow friends. So today we're going to present to you about the short assignment which is question 857 under subtopic dampened force vibration. So we are from group K and here are our group member which is me myself Muhammad Hanif bin Razak, Muhammad Irfan Faiz bin Muhammad Jasni, Muhammad Haziq bin Muhammad Rizaluddin, Nur Aishikin Soh binti Zul Arifin Soh, Muhammad Samir Saleh Al-Aqrabi, Abdullah Khan. For your information, this name already in sequence of the presentation. Okay, so we proceed with Irfan Faiz.
So first, I will read the question, which is the 20 kg variable speed motorized unit is restrained in the horizontal direction by two springs, each of which has stiffness of 2.1 kilonewton per meter. Each of the dashboards has a viscous damping coefficient, which is 58 Newton second per meter. So the question is, in what ranges of speed n can motor be run for which the magnification factor m will not exceed 2? And based on the question, these are the information that was given, which is the mass of the variable speed motor m, which is 20 kg, stiffness of both spring, which is 2.1 kilonewton per meter, and viscous damping coefficient, which is 58 Newton second per meter, and magnification factor m, which is not exceed 2. So I'll pass this presentation to the next person.
Okay, so I'll proceed with the free body diagram. So actually for this question, we are not necessary to draw the FBD because we can just substitute the info into the equation. But I'll still show the FBD looks like. Because for the FBD, since we know that the N is going anti-clockwise, so the KX and CX dot will go to the left. And for the F sine omega theta will go to the right. So that is for the X direction. For the Y direction, we have mg and also mg going downward and n going upward. But the mg and n can be cancelled out. So for the equation, so the summation of fx equal to mx double dot. So after you solve that equation, you will get the equation like you can see below, and the equation that you get can be compared to the basic differential equation of damped force vibration. I think that's all from me.
Okay, so next I will simulate. So from the comparison earlier, we assume it into two equations, which is equation 1 and also equation 2. So from equation 2, we rearrange it, so we can get that omega n is equal to cert 2k over m, and we substitute the value of the stiffness and also the mass. We substitute, do the calculation, and we can get that natural frequency is equal to 14.49 radian per second. Next, from 1, we rearrange it, so we can get that zeta is equal to 2c over 2m omega n, and we cancel out 2, and we substitute the value of efficient, mass, and also the natural frequency, and we can get that the damping ratio is equal to 0.2. Next, I will pass the presentation to Samir.
Yeah, so next for magnification factor, we put m squared equals 1 over 1 minus the frequency over the natural frequency squared, and all of this squared, and plus 2 zeta frequency over natural frequency squared also. So here the frequency over natural frequency, we let it we substitute by r. So when we calculate this, we have finally r power of 4 minus 1.84 r squared plus 0.75 equals 0. So we will have two r's here. R squared equals to 0.610, and or r squared equals 1.230. Yeah, so I'll pass it now to Abdullah.
Okay, for the finding R, we have already get the information for the 14.49 for the radius, so rate for S, and it's for the natural frequency for the N. So just basically do the substitution by the the information which you have from the calculation. So for the basically do the natural frequency over the R which we have already got, and then it will be 0.6, and for the other one will be also same thing. So we are going to 0, and then we are going to square it by natural frequency and multiply it, and then we will be getting for the natural frequency 11.32 radius per second and 16.07. Changing to the information for to be multiplied or something like that, then we have to change it to the N. So it will be revenue for the minute. We will change it from the radius to the minute revenue, and that will be that will be 108.15305 revenue per minute. Next. For the next one, it will be the range of the speed. So basically, we have already get the speed which is 1 for the revenue and 153. So it will be the range between that, and it will work. That's the basically what we have got. That's all from me.
Okay, thank you, Abdullah. So here we are in the conclusion. So in conclusion, the range of speed and motor can be run with magnification factor M not exceed 2 is N less than or equal to 108.1 revolution per minute, or N more than or equal 153.5 revolution per minute. I think that's all from us from Group K. Thank you.
Okay, thank you.